All right, so here are kind of the things in 8.5 we haven't talked about. So 8.5 talks a bit about domains and ranges, x and y intercepts, which we've already talked about. Should I remind you about x and y intercepts, or are you okay? That's looking like a please remind us.
No, that looks like x and y intercepts are.
Okay, how about this? You guys tell me, what's an x-intercept? Okay, that's where the function crosses the x-axis. So is that put in 0 or set equal to 0? Convince me, one way or the other. Yeah, this is wondering when do I get the output 0, right? That's an x-intercept is where it crosses the x-axis, right? So that's looking for something like this. That's asking a question about when is the output 0. So these guys think set f of x equal to 0 and solve. How about the y-intercept? Yeah, that's put x equals 0 in. So here you're looking to do f of 0. Okay, see that? This is an evaluate type question. These are pretty easy. This is a solve type question. These are sometimes hard. Cool. So there's x and y intercepts. For domains, which way do you smush the picture? Vertically. And for ranges, you smush horizontally. Okay. What else do we need? We need the idea of a function's positive. So f of x is positive. What do we mean by that? Like, if I said this phrase to you, what would you think?
That is not a negative number.
Yeah, the output's not a negative number, right? You guys see that? So outputs are positive. That's really what we want to think for this guy. How about if we said f of x is negative? Yeah, exactly. We'd really think to ourselves, oh, outputs are negative. Okay, 2 more phrases and then we can be done with 8.5. F of x is, well, 3 more phrases, sorry. Increasing. What do I mean by f of x is increasing? It's getting bigger. What do I mean, getting? How the heck do you read that off a picture?
Just the way it's going.
Yeah, if I increase the inputs, the outputs should also increase. Do you guys see that? So what's increase the input look like? Which way am I moving across a picture? Yeah, I'm moving the kind of usual left to right. So this really means rising from left to right. If I kind of squinted at it and thought it was a line, the slope would be positive. You guys see that? Okay. How about f of x is decreasing? What would I mean by that? Yeah. I really should think it's dropping from left or right, or sinking, or whatever the opposite of rising is. Falling, I suppose. Right, so a picture of something that's increasing would look like this, right? Picture of something that's decreasing is going to look like this. want to put all this together for a second? Oh, I lied to you. I said one more, didn't I? F of x is constant. Yeah, it's flat. Right, really that means the outputs aren't changing, right? You guys see that? Okay, so if I try to put all this together, maybe here's an example. Let's see. So let's call this point negative 1, 1. Call that point 1, 1. And we'll call this point negative 2, negative 2. And this is a crummy picture, right? I really have got my scale all kinds of dorked up on that thing. But what am I wondering? What's the question I would ask to go with my example? Yeah. Maybe classify f of x as increasing, decreasing, or constant, right? You guys see that? Is f ever really just one of, wait, is f just one of these things? No, not really. So what should I do to answer this question? If they want me to classify this thing and it's none of them, what do they really mean? How about tell me when it's increasing, when is it decreasing, and when is it constant? You guys do that? So if I just said, all right, let's classify increasing. Here? Is that what you're looking at? Okay, cool. So increasing is definitely this bit, right? Okay, so let me list the x values for which it's increasing, right? You guys see that? So it's increasing on, what are the x values for that? You guys all see that? We're going from negative 2 to negative 1. And then I should ask, what kind of brackets does this get? Close? Is it rising from left to right across this bottom? Well, on the right half it is, and on the left half it's not. So this is kind of ambiguous, right? Really, that's a point where it's neither increasing nor decreasing. Because as I come into it, it's decreasing. As I go out, it's increasing. So I'm going to leave that as an open bracket. And really, you could just remember that the brackets on increasing, decreasing, and constant, they're going to be open. How about at negative 1? Is it open or closed? It's open for the exact same reason, right? On the left side, it's increasing, and on the right side, it's constant. So I can't make a determination. You guys see that? All right. How about where is it decreasing? So increasing was the purple. How about decreasing? That stuff's definitely going down, right? How about that stuff? Is that going down? No. How about this stuff? Is that going up or down?
Well, which way are you going?
Which way are you
Are you
going?
going this way, or are you going that way?
Which way are we going?
Oh. Okay.
So we're always reading left to right. So now is this uphill or
Increasing.
downhill? Downhill. You're moving left to right. You're always going to go left to right across the picture. So if you were a little guy on here, right, you would be walking downhill, decreasing. So we're decreasing on, what are the x's? So where's that left bit start?
So that'll be infinity to negative.
Infinity to -2?
Minus and minus.
Minus? That one's easy, right? That one's open. How about at -2? Yeah, that one's open because on the left side it's decreasing. On the right side it's increasing. That means that point's kind of indeterminate, right? All right, how about the other side? What's the other side?
1 to infinity.
That's from x is 1 to infinity. Infinity definitely gets an open bracket. One's also open. Same reason. It's flat on the left and then decreasing, so I can't determine that it's just decreasing. What do I put in here? Oh yeah, I want to stick these together, right? So I put in my union symbol, stick stuff together. And where's it constant? Oh yeah, everywhere between -1 and 1. And they've got to be open because, yeah, on one side it's not flat, right? On each of those points. On the left side of -1 it's not flat. On the right side of 1 it's not flat. Is cool with this? You want to see a weird one? Yeah. No. Okay. Give intervals of increasing, decreasing, constant, and positive, negative for f of x is x cubed. You guys know a picture to go with this? Yeah, cool. The picture for x cubed is this whoop-dee thing, right? You guys see that? Okay, so what do you want to do? Positive, negative, or increasing, decreasing, constant? Increasing, decreasing? Is that one easier? Positive, negative is pretty easy. You guys want to start with that one to warm up? Okay. So I want to know when this thing is positive. So positive means that the outputs are positive, right? So where are the outputs on this picture? They're the... Which axis is the output axis? Y. So what does positive y mean? Yeah, it means y has to be bigger than or equal to 0, right? So that's that stuff, right? So what are the inputs that give me outputs like that? Yeah, all of these ones. You guys see that? Really, I'm asking, what do I put into the cubing function to get a positive number out? Well, cubing preserves sign, right? So if I want to get a positive number out, I better put a positive number in. Why did I include 0?
Still positive.
Yeah, I don't know. This depends on your definition of positive. We can include 0 in the positive numbers. How about negative? Negative infinity to 0? Right, if I'm going to get a negative number out of the cubing function, I better put a negative number in. So, oh, what kind of bracket do you put on 0? Sure. So 0 is somehow both positive and negative? Okay, so you just said that? Is that a problem?
No.
Not really. Is it weird? Yeah, a little bit. All right, so we got positive and negative. Now we're looking for increasing and decreasing, right? So where is this thing going up from left to right? If you put yourself on this and you were walking from left to right, where would you be walking uphill? This is a really good thought. Negative infinity to infinity. Yeah, does it go flat at 0? I don't know. It's a great question. You guys see that? That's actually a really good question. And that's totally a calculus question, and that's totally a question for when we have better sets of definitions. The answer would be this. But that's a really good thought. You might wonder, wait, is it flat at 0? It actually is flat at 0 for just an instant. That's something you can tell a little bit of calc. But it doesn't mean it's not increasing. Cool with this? All right. Awesome. So this is what I want you to take out of 8.5. If you can look at a picture and you can tell me where it's increasing, decreasing, or flat, and then if you can tell me what it means to be positive and negative, get a domain, a range, x and y intercepts. That's a lot of stuff,
God bless you.
right?
On a homework, when we get one of those problems and ask for increasing, decreasing, and constant, do you just only put increasing down on the paper, or do you say? No,
Yeah, that's a good question, right? I really maybe should answer decreasing and constant. When is this thing decreasing?
The opposite.
That'd be downhill, right? I'm wondering, when would I, walking across this thing left to right, when would I encounter a downhill section? Never. Never is a pretty good answer. It's not. Ever or never, or somehow phrase this to yourself. If you want to use this funny symbol, you can. This is just a math symbol, meaning there isn't anything in here. That's fine. Or you can just write ever. That's fine. I'm not worried if you use the symbol. Do not cross your zeros because they look like this symbol. How about constant? When is this thing flat? Yeah, maybe just at the 1.0. That would be weird to write as an interval, right? And I already said it was increasing there, so maybe I would say never. I might write maybe at 0. Really, I think, though, because we stuck that in here, never is probably a better answer. Guys cool with that?
We put either one of those on the test. Is there a possibility to get one wrong?
These guys?
Yeah. Or is it just preferable?
No, I'm okay with either of those. I would prefer if you phrased this as a like. Maybe? That's okay. That's a really tough question. I don't expect you guys to be sure on those. If there's a little flat spot like that, being unsure is okay. That's totally good. Cool? Questions on any of the picture stuff? Cool.